This video will not have any generative AI, not a single line of text, none of those weird shiny images, and I won't even get started talking about the videos. AI is so bad that companies have resorted to shoving it into the products we already have adopted and use in hopes that someone will start using it. On top of this, these companies are spending billions of dollars on advertising and marketing campaigns trying to convince us that this technology is the future. Now, AI has gotten better. The output has improved. And the implication that these companies want us to believe is that this trend will continue and then somehow, magically, it'll all become good. I have a simple response. It won't. AI is run on computers, and computers aren't intelligent. Without intelligence, you can't have subjectivity, and without subjectivity, well, computers won't be able to tell what is good. I didn't grow up with pets. Sometimes I'd go over to someone's house and they had this big four-legged creature that would run around, chase balls, and make a sound. Other times, people would have this smaller, soft creature with almond-shaped eyes that would lay down and stare at me from across the room, and when I got too close, well, it would get up and run away. Someone taught me that the big thing that liked to lick and bark was called a dog, and the small thing with the pointy ears was called a cat. I knew the difference instinctively. No one had to tell me that these were two different things, just what they were called. This is just how our brains work. We notice similarities and differences in everything we observe, and we're able to categorize them on our own. Nobody is taught how to think, they just do it. And without understanding how people think, it's impossible to teach a machine how to do it. Computers are a type of machine that is capable of executing any algorithm. They won't do this on their own, of course. They can only follow instructions. But what if the problem can't be solved with an algorithm like, is this a dog or a cat? One of the ideas people had was to take things humans already know and work backward. This is called supervised machine learning. It's the basis of everything we're now calling AI. Let's say we have a bunch of digital images of cats in one folder and a bunch of digital images of dogs in another folder. We can then execute some computer code to go through all the images and see if it can come up with a good way to predict if the images contain either a cat or a dog. One way to do this is to create something called an artificial neural network. Now, in order to get an artificial neural network to work, it has to go through a process called training. In this case, it will be given human categorized images that it knows contains dogs and human categorized images it knows contain cats. The goal of training is to achieve the highest possible accuracy in determining whether a future unseen, unclassified image contains either a dog or a cat. Initially, the neural network has no information, so it has a 50% chance to get the correct answer by guessing. Then it tries to improve on that score by generating random weights and biases and applying them to a hidden layer of the neural network. And if any of these new combinations show improvement, then that will become the new best neural network. And then it'll try again. Same images, new combinations, and again and again and again, until eventually you have something that's fairly accurate. It will never be perfect, but it might be pretty close. If our neural network achieves an incredible 99% accuracy in classifying future pictures of dogs and cats, that performance will still deteriorate over time. There will be new pictures, new cameras, new lights, and new dogs and cats. So as that accuracy declines, you can improve your neural network by retraining it, but that requires even more human categorized pictures of dogs and cats. Otherwise, you'll only amplify errors in the artificial neural network by retraining it on its own, sometimes incorrect output. This is why CAPTCHAs, designed to sort humans from robots, present people with pictures and ask them to categorize things within those images. It is the consensus of human observation that forms the basis for all of this stuff, which makes human intelligence a critical, necessary, and irreplaceable piece of artificial intelligence. Now, don't let the name confuse you. Artificial neural networks aren't real. You won't be able to take an MRI of a computer and see real nerve cells and real neural networks the way you could if you were to look at a human. This won't stop people from acting like artificial neural networks work like the human brain, but this isn't true. Artificial neural networks are a tool used to visualize and teach an abstract machine learning concept. Neurons are microscopic cells, and each one of our human brains contain billions of them. Studying the human brain is exceedingly difficult. It's incredibly complex for its size and a technological challenge to observe. And that's to say nothing of the ethical considerations involved in actually observing a working human brain. It would be convenient if leaving the computer on for long enough were enough to suddenly get us intelligence. But no matter how many data centers you build and how many programmers you throw at it and how much time and money you pour into trying to make the computer intelligent, it's only ever going to be close. Every single piece of AI-generated content could be produced by a human following the exact same machine instructions. Now, it would take an incredibly long time, but it could be done, retracing every step of training, of natural language processing, and finally of generating the pixels of an image or the construction of a sentence. This was the argument presented by philosopher John Searle in his thought experiment known as the Chinese room. Let's say you have a human in one room and they are following a set of instructions to write Chinese characters and slide them under the door. And in the other room is a computer that can read those instructions and produce Chinese language responses, print them out, and slide them back under the door. In Searle's thought experiment, both the human and the computer are said to be doing the exact same thing. Neither of them truly understand or know Chinese, but they are following a set of instructions they've been given in order to have a fluent conversation in the language. Through many ancient civilizations, alchemists attempted to transform base metals, such as lead, into noble metals such as gold. In many ways, lead and gold are similar. Both are metals, both are dense, soft, and malleable, but lead is common, cheap, and ugly, while gold is rare, expensive, and desirable. Had anyone figured out how to transmute lead into gold, they would have become exceptionally wealthy, especially if they were able to preserve their secret. But after centuries of writing, experiments, and practice, nobody was able to pull it off. Tales and rumors emerged throughout this time of certain alchemists who found the secret and were able to transmute lead into gold and, of course, achieve immortality. None were ever found to be true, but their impact still lasts in literature and media today. The reason none of the alchemists ever succeeded was because none of them actually knew where gold came from. Gold isn't formed here on Earth, it's formed in outer space, in the intense nuclear reactions that create all of the heavy elements. And now it is possible, due to advancements in scientific understanding, to actually create gold here on Earth. It can be done by building particle accelerators and using a tremendous amount of energy, but it does come with a hefty price tag: $1 quadrillion per ounce of gold. Let's say you're a small business owner and you've decided you want a logo for your business. This is a new idea, one you just came up with when you created the Instagram page for your business and it prompted you to upload a picture. Annoyed by the idea that your customers might see some drop ceilings and outdated carpeting, you decided that you wanted something fresh and fun. You could contract a graphic designer, although you've never done that before, and honestly, you don't really know what you want. So instead, you decided to talk to your nerdy friend, the one who wouldn't shut up about AI, and ask him how to do it. And soon after, you now have your membership with an AI image generation site. You make a mental note to cancel your subscription later, one you'll immediately forget, but you get to work and enter in a prompt. And just like that, there are now all these images, and one of them you actually really like. It has really good colors, you like the shape and design of it, but there's just one problem. The name of your business is not spelled correctly. So you try the prompt again, this time adding the words spelled correctly to the end of it, and, well, they're all completely different. After several hours of different prompts and a bunch of different images, you realize that you've already burnt through all your image generation credits, and you haven't really found that perfect logo yet. But out of all the options, there is one that you can live with. Although there are some problems with it. The shape is a little bit weird, and when you look at it, it kind of looks like the text isn't actually on the logo. It took you a while to notice that stuff, so you hope that other people won't. You upload it and move on. You're a busy small business owner and you have much better things to be doing with your time. In 1950, brilliant mathematician and computer science researcher Alan Turing said the following: "I believe that at the end of the 20th century, the use of words and general educated opinion will have altered so much. One will be able to speak of machines thinking without expecting to be contradicted." Turing outlined a challenge where an average interrogator would go into a room and type on a computer terminal. They'd have 10 minutes to evaluate whether the person they were typing to was either a human in one room or a computer program in another. Turing's prediction was that these average interrogators would only be 70% successful in choosing the human. Well, the end of the century came and went, and no program ever passed this Turing test. Then, another near quarter of a century has passed, and still, no programs have actually come close. It turns out, humans are really good at figuring out what is another human and what isn't. They're also really good at using the computer. And most of all, they prefer using the computer to chat with actual humans. But Turing wasn't entirely wrong. People do think of the computer as intelligent. They give it human characteristics all the time. Loading screens are thinking, and system messages are what the computer is showing or telling us. In fact, people became way too trusting of their computers. The vast majority of cybercrime takes advantage of not vulnerabilities in the computers themselves, but in the humans using them. For criminals, it's become so much easier and cheaper to deceive people with fake social media profiles, websites, and emails than it ever would be to do some real hacking. Businesses aren't throwing AI into every advertisement and existing product because the technology is good. It's too late for that. Instead, they've created something that can only really be used for deceptive or nefarious purposes, which means that they are desperately looking for legitimate use cases to justify their investment. What does AI actually do? It deceives people. These tools are designed to mimic the work people can do and present it as work people did do. That's the best case that executives of the most powerful companies in the world can come up with. So who would want to use this deceptive technology? So far, the answer's been students who want to cheat on their academic assignments, criminals who want to steal money by deceiving people, predators who want to create abusive images, and talentless hacks. This doesn't really make a market, and it certainly has the potential to raise some eyebrows among regulators. AI products need to be tacked on to actual useful products so it doesn't give the game away. The crowning jewel achievement of all these AI startups has been developing technology that can generate any image or song using just a simple text prompt. And people are either saying, "No thank you," or they're saying, in 1997, IBM supercomputer Deep Blue defeated world chess champion Garry Kasparov in a widely publicized 6-game match held in New York City. Leading up to this point, computer scientists, hobbyists, and researchers had spent decades building better and more powerful chess programs, but none of them were able to defeat the best players in the world. Chess is a game that is simple to learn and play, and difficult to master. For over 1,500 years, people have been playing, studying, and thinking about chess. The love of the game has spread to every corner of the globe and has been passed down from generation to generation. Chess is a game you can play and watch for your entire life, and you may never see the same game twice. Divergence happens quickly, with each move creating a new universe of possible moves and outcomes. Top players are able to look deep into the future of any chess game and see all the possible outcomes that can result from each different smart move. Average players are only able to evaluate a few steps into the future, and this makes the computer a natural choice for chess playing. It can brute force its way with its memory and its speed through many possible outcomes that could result, and potentially predict better outcomes. Still, it took decades before computer programs were able to beat the best players. When it finally happened, the media portrayed it a bit as a victory for machines and a defeat for humans. But Garry Kasparov did not lose to a supercomputer in 1997. He lost to Feng-Sheng Su, Murray Campbell, Thomas Anantharaman, Arthur Joseph Hone, Jerry Brody, and Joel Benjamin of the Deep Blue team, as well as the thousands of other people who developed all the hardware and software that was necessary to run the Deep Blue program. When IBM sponsored Deep Blue versus Garry Kasparov, they saw a great marketing opportunity. But still, they hedged their bets. Deep Blue lost the 1996 match by a significant margin. So for the 1997 match, IBM upped the prize to $700,000 for the winner and $400,000 for the loser, with IBM keeping whatever prize they won. Project was well understood to be a vanity project, an expensive research and development project on state-of-the-art hardware designed to do exactly one thing: play chess. IBM stock had taken a nosedive in the early 1990s. The company took drastic measures, cutting 60,000 jobs in the largest layoff in US history. The move was shocking because IBM had long been considered the best employer in the world. In its restructuring, a different corporate strategy emerged, one where the mystique and reputation of the company would be laundered through various marketing campaigns to push the company into new, more profitable products and services. In a speculative bubble like the dot-com bubble of the late 90s, companies were able to increase their stock price by announcing they had some new, more powerful, and more specialized technology than their competitor. In 2011, IBM unveiled Watson, a powerful supercomputer that could do exactly one thing: play Jeopardy!, the hit television trivia show. Watson, like Deep Blue, was created by a team of researchers to take on the best Jeopardy! Players in the world: Brad Rutter and Ken Jennings. IBM won, this time by blatantly cheating. Watson was fed a direct electrical signal that told it when it could buzz in, while the human players were forced to anticipate the timing of the question in order to beat Watson. But none of that really mattered because this time IBM was ready. Since that televised Jeopardy! Game, Watson has been everywhere, and it's a brand that is synonymous with artificial intelligence and machine supremacy at human tasks. Big tech needs the next big thing. Many of these companies were built on the promise of endless future growth. But how do you grow when you already have total control of the market? What happens when everyone already uses your operating system, and everyone already uses your hardware, and everyone already uses your software, and everyone already uses your social media? Well, you look inward, and what do you find? Well, you've got these pesky things called employees, and they cost a lot of money to employ. So what if instead you could replace those employees with an artificial employee, AI? Then you wouldn't be bogged down with pay and benefits and end-of-quarter pizza parties. If you're an employee, AI is clearly a threat. And if you're a business owner or a manager, AI is the indulgent fantasy of endless profitability, of value divorced from human labor. Now, if AI was good and it worked and it was truly intelligent, then yeah, you wouldn't need employees anymore. Everyone would be laid off, and well, then no one would be able to afford anything. And also, if science fiction is any sort of reference, humanity would have to fight in a war against the machines in which we'd almost certainly lose. But that's all fantasy. And no matter whether it's the Philosopher's Stone that turns lead into gold, or Willy Wonka's Oompa Loompas, or generative AI, humans will always have fantasies of power and endless wealth with no costs. 3 Mile Island Nuclear Generating Station, located just outside Harrisburg, Pennsylvania, had a major nuclear incident. And from 1979 until 2013, no new power plants started construction. Behind me are 2 nuclear reactors that provide power to almost 2 million homes. And coming out of those cooling towers is water vapor. This is a completely clean source of energy. But following the 3 Mile Island incident, America improved its power grid by building CO2-emitting power plants using sources like coal, oil, and natural gas. In September 2024, Microsoft announced that they had secured a deal to reopen one of the reactors at 3 Mile Island. The deal gives Microsoft enough power for 800,000 homes over the next 20 years. But the homes won't be getting this power. Instead, this will go to powering and cooling Microsoft's data centers. This is a big deal. Either 2 million people could have all their homes' power needs met, or Microsoft could use this to develop more of their software products, including possibly AI. And this could mean that we're in for a lot more email summaries, chatbots, shiny images, and horrible videos. We've been told for years now that AI is only going to get better, that this is the technology of the future and soon everyone's going to be using it, and I don't get it. I don't see the vision. All I've ever seen is garbage, deception, and deflection. I've had so many people in my life try to show me something they've created with AI, and every single time I am totally unimpressed. It's just embarrassing. I think maybe they'd enjoy painting on their own, or learning how to write, or learning how to play an instrument, or do anything. And instead, they're just showing me something that they didn't even make. Maybe they could do this if they weren't so afraid that AI could do it better. If you're watching this and you're thinking about doing anything new, or different, or fun, or hard, or exciting, just do it. Do not be afraid that it's not worth it because AI is going to do it someday. Because no matter what, no matter how hard it is, no matter how difficult it seems to be as good as other people, at least you'll have tried. You'll experience pain, pride, joy, frustration, anxiety, and exhaustion, but you'll have felt that. So go out there and do anything, feel anything, try anything. Whether you like it or not, at least you had an opinion, at least you tried.